Okay, good evening, morning, whenever you're watching this, everyone. So, the recent CFA didn't go all that great, and that's okay though, because we learn. And so, what we're doing is love you. What we're going to do is we're going to go over. This is the worksheet that I posted on the Google Classroom. So if you want to download that and kind of have it with you as you're watching this, that'd be great. But basically, what I want to do, the good news is that in looking at what you guys did versus what was expected of you, most of you are only one or two small little tweaks away from getting it really well. Unfortunately, when you have an answer that's either right or wrong, those small little tweaks mean everything. So, you could understand 90% of it, but that last 10% is going to stop you from getting it right. And so, therefore, a lot of you guys ended up with zeros and ones and twos. We only had a handful of fours and fives. I think probably less than five across all three classes. So, not to be discouraged. Just means we need to work a little bit at it and clean things up a little bit. So we're going to go over all the problems tomorrow in class. But I also wanted to give you this so everyone kind of understands what it should look like. The first thing I want to go over is, so these are exponential functions. If you notice, this paper is split into graphing four exponential functions and then matching a graph of an exponential function with its equation. There are two of those. Four of those, sorry. And then we have a couple logarithms. So then we have we have two logarithms that we're graphing. The reason I only did two is because that's what we've done most recently, so that's what you guys should be most familiar with. And then matching an equation to the graph. And I think we have four of those. And that's it. So let's go through it here. So let's start on, before we go, just some basics. The generic exponential function looks like this. What's up, Fee? With this being kind of our key. Now, I'm going to draw out four versions of this that kind of cover everything. Now, we know H moves left and right, K moves up and down. H is for horizontal, left, right. K is for vertical, up and down. So if we have 2 to the x, okay, your basic exponential function. It's going to cross here at 0, 1. And the asymptote is always going to be at y equals k, or f of x equals k, rather. So in this case, where we just have f of x equals 2 to the x, k equals 0. So that's why we have that right there. Now, if I go negative f of x equals negative 1 times 2 to the x, that is going to flip this over the y-axis like that, and this point now becomes 0, negative 1. Okay? Now, if we have f of x equals 1/2 to the x, kind of like that. We still have this point 0, 1, because if we put a 0 in for x, we're raising 1/2 or whatever it may be to the 0 power. And anything raised to the 0 power is 1. And then if we have f of x equals -1 times 1/2 to the x. Same general idea, we're going to flip it over the y-axis, or the x-axis, and this still is 0, -1. So these are your 4 basic exponential functions. Know these. Like, just stare at this and memorize this. Right? Get this. And then h and k, move it left and right. That's it. Remember, and this is so important and something that everyone struggles with. When I have an h, so I have a times b to the x minus h. If I put a 2 in there, that becomes x minus 2. Because that negative is kind of baked into the equation, this 2 moves it 2 to the right. If I wanted to move it 2 to the left, I'd have to put it in -2, which would end up looking like this. Okay? So know those. We'll go over logarithms when we get there, but really, you guys, if you understand that this is what the 4 basic exponential functions look like, you're going to be fine. Let's go all the way back up to number 1. So number 1 asks us to sketch a graph of each function. We have 2 to the x minus 1 minus 2. Oh, yay. I love it when it does that. Just skipped a little bit. So, in general, so we start off with this point, and I'm going to draw this in black. And that's kind of what the graph would look like, right? Now, if I just did 2 to the x minus 1, it's going to shift it 1 to the right. Like that. And then down 2. Remember, this is left to right. And when I add k in, that's up and down. So I'm going to go down 1, 2. So this point of inflection now is 1, -1. And the whole graph moved with it. And there you have it. And as always, our asymptote was y equals k, which in this case is -2. Okay? So notice we have the same basic function. All we did was we moved it 1 to the right and 2 down. So here, if I'm looking at those 4 basic graphs, this 1/4, that's going to have the same general shape as these guys right here. Because it's a fractional base. And then I know that this 1 right here is going to move it 1 to the, nope, not 1 to the, 1 to the left. And that one's going to move it 1 up. So we know we have this, we're going to have this general shape that looks like this, because that's the 1/2 to the x or 1/4 to the x. They're both going to have the same general shape. And then we're going to move it 1 this way, 1 up. So I know that my asymptote is at y equals k. I would normally start off there at 0, 1. I'm going to move 1 to the left and 1 up. And I know that the shape looks like that. So when all you're being asked to do is match up, what's up, Fee? Is match up the graph to the equation. That's all you need to do. Just know the general shape of it. Know whether it starts high on the left or high on the right. And know whether it opens up or opens down. And if you know those basics, you're halfway there. So here we have 3 to the x, so we know it's going to kind of go like that. This plus 1 is going to move it 1 to the left. And that minus 2 is going to move it 2 down. We also know that this right here is going to be our asymptote. So we know negative 2 is our asymptote. We normally start at 0, 1. We move 1 to the left, 2 down. And we know that because it is our regular shape, it's going to look something like that. And here's the thing. When you look at the answers that any problem gives you, there's only going to be one that looks like that. There may be one that looks like this, that moved 1 to the right instead of 1 to the left. But that's as close as it's going to come. There aren't going to be ones that are like here or here, right? There aren't going to be those little micro transitions. Rather, it's going to be something big. So let's move on to number 4. We have 1/3 to the x, so we know the general shape is going to be like this. That plus 1 moves it 1 to the left and down 2. Notice that we have the same shift. We just basically have the opposite graph. So we're still going to move 1 to the left, down 2. We're still going to have our asymptote at y equals negative 2. Except we're going to open up this way instead. Okay, and it really is that easy. If you're having difficulty with this, if you're not sure how to graph it, go back, watch it again. If you're still not making it sense to you, come in, talk to me. We'll figure out a way for it to make sense. That's what AOT is for. Write an equation of the graph. So I'm just looking at this, and I go, okay, it's this way, so I have a fractional exponent. 1/2, 1/3, 1/4. Okay? I know I normally start there, and this is the place that I do, so it moves over 1, down 2. So I'm going to have f of x equals 1/2 to the x minus, and then I'm putting a negative 1 in there. So that's going to turn into a positive 1, and then I move down 2. So fraction, that could be 1/2, 1/3, whatever. But it's plus 1 minus 2. And look at what we got. Plus 1 minus 2. Even if I wasn't sure about this right here, the interesting thing is that it's the only one that has the plus 1 minus 2. Plus 2, nope. Plus 1, check. Plus 2, nope. Plus 2, nope. Plus 1, nope. So that's our baby. Okay, without even looking at the answers, let's look at number 6. Okay, so we're going to have a 2 to the x, 3 to the x, 4 to the x, one of those. And this is the point we're looking at right there. So we move 2 to the right and 1 down. That makes it a negative 2 plus 1. Remember, this is my h. It goes left and right. This is my k, goes up and down. So we're looking for with this being 2, 3, or 4. And again, the only one that even remotely looks like it is C. I'm going to be honest with you, though, guys. You're going to get a lot on the CFAs. It's going to be a lot of a closer call. You'll get like 4 to the x plus 2 minus 1, stuff like that. Okay, we got 2 more of these. So we've got a fractional, whoa, excuse me. So we have a fractional exponent, just like we had up here, where we're going to have 1/2, 1/3, or 1/4. The CFA or anything, you're not going to get like 1/3 to the x minus 2 plus 2, and then 1/2 to the x minus 2 plus 2. That's not going to happen. They're going to give you a fraction here. You're going to need to understand it's a fraction. And then you're going to need to understand what the shift is. So here, what we want to do is we want to look at how frustrating I'm getting at this. How frustrating I'm getting. Freudian slip. How frustrated I'm getting. We want to look at this point right here. So we start off at 0, 1. And what do? We moved 1 left. That's -1. And then up 2. That's +2. Okay? So when we have x, so this is my h, this is my k. When we have x minus h, and we put in a -1 right there, that's going to turn into 1/3 to the x plus 1 plus 2. So this is what we're looking for. +1 plus 2 with a third base, +1 plus 2. Check right there. Once you understand the basics of it, it should flow fairly quickly. So, fourths we're looking at. Cool. Oh, there's a 1/4 and a 1/2. But it doesn't really matter. So 1/4 or a 1/2. Let's just say it doesn't really matter. So it's a 1/4 or a 1/2. Right? Because we know because it opens this way. If it opened that way, up to the right, this would be 2 to the x, or 4 to the x. But because it opens up to the left, it means I have to yawn. So we start off at 0, 1, and we're going to match it up with this point right there. It's called the inflection point. What you're looking for is kind of where your graph goes from a kind of gentle curve up to a super steep curve up. The more you look at them, the more you get familiar with them. So this went 2 to the right, left. That's my h, -2. And then 1 up. That's +1. That's my k. So remember that this is going to be minus h minus h. So when I put in a -2 there, +1 +1, what this ends up looking like is 1/4 to the x plus 2 plus 1, or 1/2 to the x plus 2 plus 1. So let's now look at our answers. +2 + 1 right there. So notice why I said it ended up not really matter, because even though they have a 1/4 here and a 1/4, or a 1/2 here and a 1/4 here, and they're like, oh, look at us be so tricky, you can eliminate the 1/2 because of that -2 right there. Okay. Domain and range. So now we're at logs. So let's quick review logs. So this is the one I'm using for 2. That's time anytime this number is greater than 1. So we log 2 to the x, log 3 to the x, log 100x, whatever. And the basic graph looks like this. And 1, 0. Notice it's called an inverse function. We're switching it. So 1, 0 is now our kind of central point, that inflection point. Need to drink some water. Give me a second. Now, if I have log base 1/2 to the x, log base 1/3 to the x, anything like that, it's going to swoop in like that. And again, 1, 0. Okay? So, again, look at these, know these. If it's a fraction, it starts up high, swoops low as we go left to right. If it's a whole number, it starts low, swoops high. So, let's look at this really quickly. This 3, so we're going to have something that goes like this. Starts down low, moves up. This is a plus 2. Remember that that's for x minus h. So in order to get a plus 2, I need to add a negative 2 in there. So that moves it 2 to the left, plus 5 up. Now, previously, when we were looking at these, notice that we always had the asymptote of k. Asymptote of k. Asymptote of k. And they were all horizontal asymptotes. When we're dealing with logarithms, we're talking about we're talking about vertical asymptotes. And h is going to be our asymptote. And then we move up 5. So we start off at 1, 0. And then we're going to move back 2, 1, 2, and then up 5. 1, 2, 3, 4, 5. So we're going to be right up against the asymptote this whole time, and then swoop out like that. And that's our graph. Domain. Your domain, you guys, and this is really important, your domain in a logarithm is always going to infinity. So here we have -2 to infinity. And your range will always be in a logarithmic function -infinity to infinity, or all real numbers. If you need more time with it, just pause, rewind, whatever. So again, we have a whole number right here. We don't have a fraction. So we know it's going to be one of these bad boys, because this moves it 1 to the right. And it moves it 1 up. So remember, we started at 1, 0. Move over 1, up 1. And there we go. So before I even look at the graphs, log base 2, I know it's going like this. Plus 2 here, I know it moved 2 to the left. And my asymptote is going to be at -2. Plus 3 up. So that means the point, I start off at 1, 0. I'm going to move back 2. That's -1, 0. I'm moving up 3. That's -1, 3. So when I look at these graphs, -1, 3 should be an important point as the graph goes like this. So let's look at these 4 right away. And unfortunately, all 4 of them are opening the right way. Let's even frustrating, but it's okay. The domain, so we put down as -2. So that means that our asymptote needs to be here. Here, that's not what we're having. Here, nope, it should be right up against it. Or here. Okay. Domain, x is greater than all real than -2. X is greater than -2. So now what else happened? Well, we know that it shifted up 3. Right? So we started here at 1, 0. We went back 2 and then up 3. Okay, that seems to work. So this is looking good. Let's go check down here. We started at 1, 0. Move back 2, up 1, 2, 3. And that is not a point right there. So we're going to go with A. So here, number 12. Again, we have one that looks like this. But now I know I put in a +1 for my H and a -3 for my K. Let's move it down 3, 1 right. And more importantly, I know that that's this -1 right there. That's a +1, so I know H equals +1. So I know that that's where... Nope. Nope. There we go. So our asymptote is at 1, so we know that's what the graph's got to be right up against. So now let's look between, again, same thing, between D and A. D and A, not DNA, like, you know, what forensic people use. Move down 3. So we start at 1, 0. Move over 1, down 3. Nope. And so let's check over on D. Start at 1, 0. Move over 1, down 1, 2. Hey. There we go. So this is going to be our answer right here. Got 2 more. Again, it's a 3. It's up like this. Apparently want to be over there. It moves 2 to the left. What's going on here? To the left, 4 down. So this could be it. We're going to the left and 4 down. That's not it. That's to the right. And to the left. And remember, it was 4 down. So that's going to be, this goes, starting here, it's going to go to the left and 4 up. And that's not what we want. So that's off. If this isn't making sense to you, make sure you come in during AOT. Last one. Which, of course, this is never going to let me do. This +4 moves 4 to the left. -5, 5 down. And it goes like this. So we're looking something on a graph, 4 left, 5 down, that's going to kind of go like this. So no, no. So we're looking at C and D here. Notice that this one went 4 to the left and then up, which is wrong. This went 4 to the left and then down. which is correct. So hopefully this helps. I did get some other questions on things like expanding and contracting. But the next thing we're going into is solving equations with logarithms. I think that's probably a question better for there. Right now, the CFA is focused on the graphs and the properties of graphs. So I think that it's important that you guys really focus on those, and everything will catch up later. Have a wonderful evening, everyone.